the topic what is differentiation. Two parts we'll be studying here. First we will look at average change, and secondly the most important, instantaneous change. We will be looking why we don't want average change, why do we don't want average change, and we will be more interested in instantaneous change. So starting by average change here, this is a function x1 x2, a function value is y1, y is a function of f of x, x is independent variable and y is dependent variable here, and I am checking how much y changes if I changes the value of x1 from x2. So I am finding delta y by delta x, and the value of x changes from x1 to x2. At x1 the value of y is y1 and x2 the value of y is y1, so delta y by delta x here is 0. This is the average change of a function, how much the value of y changes if we change the value of x. Here the value of x at x2 the value of y is y1, at x1 the value of y is y1, and we see the answer is 0. We can see from graph there is a change of value, the y has changed in between a lot, but the average change from x1 to x2 is 0. It is moving upward, and with the same amount, with the same gradient, it is moving downward. So the average change is 0, and a lot of information is lost in this process. So that's why we are going to study differentiation or the instantaneous rate of change. We are interested what is the rate of change. If I am standing at this point, I will be going downwards or I will be going upwards. We are interested in this. What would the function behave at just the next step? When I take the next step, or when I am going to take the next step, whether the function will be increasing or decreasing. I am interested in this instantaneous change. Now let's look at how I will define the instantaneous rate here. I will say delta y by delta x. I will say the similar thing, but here I will make sure that x2 is very very close to x1, such that if x2 in this function, I will make sure that x1 is this value, then our x2 is very very close to such that x2 minus x1 delta x is very very close to 0, and this will give us the instantaneous change. I am finding delta y by delta x, how y changes its value to x, but here I am just making sure that x2 is very very close to x1, so that our information do not get lost here. So let's take a function here, y equal to x square. I am finding delta y by delta x. I am making sure that delta x approaches 0, but delta x should not be equal to 0. This point, if delta x is 0, then there is no change in x, so there will be no change in y, and answer will be 0 by 0. That's why I am saying again the delta x should not be equal to 0. It must be sufficiently very very close to 0, but it should not be 0. So in the above function, let's plot it. The value is delta x. Suppose I change its value x changes its value to x plus delta x. So y at x, the value of y is x square, and At x the value of y is x square, and at x plus delta x the value of y will be x plus delta x square. I will be solving this equation now. This will give me x square plus delta x square plus 2x delta x minus x square divided by x will cancel out x, only delta x. Looking at this one, x square will cancel out this x square, this delta x will cancel out this x, delta x and this x. So the instantaneous rate of change will be 2x plus delta x. So our delta y by delta x will be 2x plus delta x. And what would happen if delta x approaches 0? Delta x if approaches 0, then delta y by delta x will approach 2x, and this is how the instantaneous rate. We can check it by plotting the function and plotting the points here. This is y equal to x square at value 2, x square value is 4, at 3 the value is 9, and here I am taking delta x equal to 1. If delta x equal to 1, then I will get 3 minus 2, 9 minus 4 is equal to 5. I can plug in the values here in 2x plus delta x. 2x plus delta x here. X is 2. So 2 into 2 plus 1 equal to 5. Lot of information is lost here. But yes, this function works correctly. Give me delta y by delta x. So this delta y by delta x is known as differentiation, which I was founding. What is differentiation here? Differentiation is delta y by delta x approaches 0, but delta x is not equal to 0, which I will write here dy by dx. If dy by dx, if dx here I am saying delta x is not equal to 0, if delta x, if I am writing if delta x equal to 0, then there will be no point, because we are standing at the same point and we are approaching the same point, so y will be same and answer will be 0 by 0. So I'm again saying dy by dx will be, I can write dy by dx equal to delta y by delta x. It will be equal to the rate, it will be equal to average change when delta x approaches 0 but delta x is not equal to 0.